In this video, we're going to focus on real numbers. What are real numbers? A real number is any number that can be placed on a number line. Another way to understand what a real number is to know what an imaginary number is. Real numbers are not imaginary numbers. So what are imaginary numbers? If you see an I next to a number, 5i, negative I, those are imaginary numbers. I is equal to the square root of -1. You can't plot the square root of -1 on a number line. It's just not going to work. So the square root of -4, that is an imaginary number. That's equal to 2i. The square root of -9, that's also imaginary. That's 3i. So these numbers are not real numbers. So any number that's not in this category, those are real numbers. So now let's focus on real numbers. Real numbers can be broken up into two categories, rational and irrational numbers. Now, before I give the definition of these two, let's talk about the numbers that are included in this category. First, we have integers. Integers are numbers such as -3, -2, -1, 0, 1, 2, and so forth. Next, we have whole numbers, which are integers starting from 0. So this is going to be 0, 1, 2, 3, 4, and so forth. And then next we have natural numbers. Natural numbers are whole numbers, but starting from 1. So 1, 2, 3, 4, those are natural numbers. Now, a rational number is any number that can be put in a fraction. Let's say a over b, where both a and b are integers. So 3 over 4. 3 is an integer, 4 is an integer. 3 over 4 is a fraction, and that is a rational number. 3 over 4 is 0.75 as a decimal number. 0.15. This is a rational number because you can express it as a fraction using integers. 0.15 is 15 over 100. And you can reduce that. If you divide both numbers by 5, 15 divided by 5 is 3. 100 divided by 5 is 20. So 0.15 can be reduced to 3 over 20, which means 0.15 is a rational number. We can write it as a fraction of two integers. Now let's talk about why whole numbers, natural numbers, and integers are rational numbers. Remember, a rational number is any number that could be put as a fraction using two integers. So the natural number 4, why is that rational? Well, we can write 4 as a fraction of two integers. 4 is equivalent to 8 over 2. Think about the integer -3. We can write that as a fraction of two integers. We could say this is -12 over 4. Or we could say it's -3 over 1. So all of these numbers, whole numbers, natural numbers, integers, you can put them into fractions using integers, which makes them rational numbers. And everything that we've considered on this side so far are real numbers. So now let's talk about the other half of real numbers, that is irrational numbers, and a rational number cannot be put in a fraction of two integers. So for instance, the square root of 2. This is equal to 1.414213, and it goes on forever. You can't write this number in terms of two integers using a fraction. Irrational numbers, they tend to be non-repeating decimals, and they are non-terminated. They go on forever. You know what? Let's write that down. So non-repeating and non-terminated decimals. Another example of this is the number e. If you type in e in your calculator, you'll get 2.7182818, and that just keeps on going. So this is an irrational number. It's not repeating, non-terminated. Next, we have the number pi. Pi is a 3.1415926, and this goes on. That's non-repeating and non-terminated. So that's going to be an irrational number. You can't put pi in terms of, you can't write it as a fraction of two integers. So pi and the square root of 2, those are irrational numbers. But they're still real numbers though. You could plot it on a number line. Now I do want to mention something regarding e because it does look like there's a portion that's repeating. The 1/8, the 2/8, and the 1/8. But when you write out this number, you'll see that in the long run, it's not repeating. It's 2.7182818, and then there's another 2/8 after that, and then it's 459045. So ultimately, it's not repeating, even though this part appears to be repeated. So e is an irrational number. Now let's go back to rational numbers. 0.375, this is a non-repeating, but it's a terminating decimal. It doesn't go on forever. So non-repeating, terminating decimals are rational numbers, which are still real numbers. We can put this as a fraction. This is 375 over 1,000. And of course, you can reduce that fraction. Now, the next type of rational number are the ones that have a repeating decimal. It's repeating, but non-terminated. So I'll give you an example of that. So 0.2 repeating, 0.2222, which we can write that as 0.2 with a bar on top. That's equal to 2 over 9. That's a repeating, but non-terminating decimal. Another example is 0.4444. That's 4 over 9. That's repeated, non-terminated. But note that we can put this as a fraction using two integers. Therefore, these types of decimals are rational numbers, which makes them real numbers. So let me give you another example. Let's say we have this one, 1.232323. So this goes on forever. It's repeating, but non-terminated. So we can put that as a fraction of two integers. That's 23 over 99, which makes it a rational number. Now let's work on some practice problems. Describe each number as a real or imaginary, rational, irrational, whole, integer, or natural number. Feel free to pause the video and work on these problems. Let's go ahead and work on this problem. The square root of negative 16, is it a real number or is it an imaginary number? The square root of 16 is 4. The square root of negative 1 is I. But the way you can simplify it, you can write it like this. This is the square root of 16 times the square root of negative 1. The square root of 16 is 4. The square root of negative 1 is I, so you get 4i. The fact that there's an I means that it's not a real number. It's going to be an imaginary number. So that's it for the first part of the problem. Now, what about 3 pi? Is it real or imaginary? If you don't see I, it's going to be a real number. If it's not imaginary, it's a real. Now, we know that pi is a non-repeating, non-terminating decimal number, so automatically it's going to be irrational. Now, what about negative 14? There's no I component, so it's not imaginary, it's real. Is it rational or irrational? Negative 14 can be written as a fraction using integers. Negative 14 over 1, that's negative 14. Negative 28 over 2, that's also equivalent to negative 14. So that makes it rational. Now, negative 14, it's not a whole number. It's not an integer, nor is it a natural number. Now, what about 6e? What would you say about that? Well, there's no I next to it, so it's not imaginary, it's real. We know the number e is a non-repeating, non-terminating decimal number, so automatically it's going to be irrational. Now, what about negative 7 over 4? We can plot that on a number line, so that's going to be a real number. It's already a fraction using two integers, so it's not irrational, but it's rational. Now, because it's a fraction, it's not a whole number, it's not an integer, nor is it a natural number. So I'm just going to write fraction 9i. The fact that we have I means it's not real, but it's imaginary, and that's all we can say about that. 0.29 repeating, so we have a repeating non-terminating decimal, and we can write this as a fraction. This is 29 over 99. Now you could plug that in your calculator if you want to. So any fraction using integers, that's a real number, and it's going to be rational as well. Positive 6, that is definitely a real number. It's also rational. We can write that as a fraction, 6 over 1, 12 over 2, 18 over 3. Now, positive 6 is an integer. It's also a whole number, and it's a natural number. So we could describe it 5 ways. It's a real number, it's rational, it's an integer, whole number, and a natural number at the same time. Go ahead and work on the next 4 examples. Let's start with the square root of 3. And what about the square root of 9? Which one is real, which one's imaginary? Well, none of them are imaginary. There's no I. We're not dealing with the square root of a negative number. So both of these are real. The square root of 9 simplifies to 3. So that makes it rational. And because we're dealing with 3, that's an integer, it's a whole number, and it's also a natural number. Now, what about the square root of 3? If you type in the square root of 3, you're going to get 1.73205, and this keeps on going. So what we have is a non-repeated, non-terminating decimal. It's a real number. You can plot it on a number line, but you can't write it as a fraction of two integers. So it's not rational, it's irrational. So when dealing with square roots, you need to determine if it simplifies or if it doesn't. If it simplifies to an integer, like the square root of 9, then you know it's going to be real and rational. The square root of -25, it simplifies to an integer, but there's an I in front of it, so it's not real. You know, that makes it imaginary. Now, what about 0? 0 is a real number. You can plot it on a number line. It's rational. You can write it as a fraction. You can write it as a fraction of two integers, 0 over 5. Both of these are integers. They equal 0. 0 over -8. They're both integers. They equal 0. So 0 is rational. It's an integer. It's a whole number, but it is not a natural number. Now, what about 0.27? We have a non-repeating terminated decimal. 0.27 can be written as a fraction, 27 over 100, which makes it a rational number. And because it doesn't have an I next to it, it's real. So it's real and it's rational, but it's not a whole number, integer, or natural number. Now, next up, we have 0.531 repeating. The 5 is not repeating, but the 31 is. How would you describe this number? Well, we know it's a real number. We can plot it on a number line, but is it rational or irrational? Let's write it out and let's see if we can put it as a fraction of two integers. So this is 0.53. Well, the 31 repeats, so it's going to be 31 and then 31, 31, 31, and so forth. How can we put that into a fraction? Well, we need to identify the repeating element, which appears to be 31, but in actuality, the repeated element is 1, 3. I'm going to add another 3 here, so we're going to subtract this by the repeated element of 0.13. If you try to subtract it by 0.31, notice that the numbers don't match up. This 1 is going to be matched with the 3 down here, and then the 3 above it is going to match with a 1 down here. So what does not correspond to this 3, and this 3 does not correspond to the 1, so therefore it's not 3, 1, but it's actually 1, 3. If we subtract the first number by 0.13 repeating, note that the numbers match up. So this part right here cancels with this part. So we have 0.53 minus 0.13, which is 0.4. So 0.4 is the non-repeating part of this number. So what does that mean? 0.531 repeating, which is this number, can be rewritten as 0.4 plus 0.131313, so forth, or 0.13 repeating. When you add these two numbers, you get this number. Now, 0.4, we can write that as a fraction. That's 4 over 10. 0.13 repeating, we can write that as a fraction. That's 13 over 99. Now, 4 over 10, we can write that as 2 over 5. So to combine this into a single fraction, we need to get common denominators. I'm going to multiply the first fraction by 99 over 99, and the second fraction by 5 over 5. 2 times 99 is 198. 5 times 99 is 495. And then 13 times 5 is 65. 198 plus 65 is 263. So you could type this in your calculator, type in 263 divided by 495, and you should get 0.531 repeating. You should get this number. So the fact that we can put it as a fraction of two integers means that it's a rational number. Now, let's consider some examples with cube roots, given that we've considered a lot of examples with square roots. So let's start with the cube root of 8, and then we'll have the cube root of -27, and the cube root of 10. And then the fourth root of -16, the fourth root of 81, and the fourth root of 20. So the cube root of 8, how would you describe that? Well, first see if you can simplify. The cube root of 8 is 2, because 2 times 2 times 2, 3 times is 8. So we could simplify that into an integer, which makes it real, it's rational, and it's an integer. It's also a whole number and a natural number. Now, what about the cube root of -27? Is that real or imaginary? Now, you need to distinguish the square root of, let's say, -16 from the cube root of -27. The square root of -16, that's not a real number. That's 4i. The cube root of negative 27 is a real number. That's negative 3, because negative 3 times negative 3 times negative 3, 3 times, is negative 27. Negative 4 times negative 4 is not negative 16, it's positive 16. So the key here is to look at the index number. If the index number is even, and if you have a negative inside of it, it's going to be imaginary. If the index number is odd, it can never be imaginary, regardless if it's positive or negative on the inside. So that's what I want you to gather from this section of the video. So we could simplify the cube root of negative 27 to negative 3. Negative 3 is an integer. So that means this is a real, it's rational, and it's an integer.
Then it'd be a real number, it's going to be rational and an integer. It's not a whole number, it's not a natural number. Now, what about the cube root of 10? Well, that's a positive number, so it's going to be real. Is it rational or irrational? The cube root of 10 doesn't simplify into a nice integer. If you type in 10 raised to the 1/3, which is equivalent to the cube root of 10, this is going to be 2.154434, and it keeps on going. So this is going to be irrational. The fourth root of negative 16, we can write this as the fourth root of 16 times the fourth root of negative 1. The fourth root of 16 is 2. The fourth root of negative 1, that's like taking the square root of negative 1 inside of a square root. The square root of negative 1 is I. So what we really have is a square root of I, which is not going to be a real number. The fourth root of 81 is simply 3. 3 times 3 times 3 times 3, 4 times is 81. So that makes it real, rational, it's an integer, we have a whole number, and a natural number. The fourth root of 20, that's 20 raised to the 1/4. That's 2.114742527, and I'm sure it's going to continue. So it's a real number, but it's a rational number. So when dealing with square roots, cube roots, fourth roots, if it doesn't simplify to a nice number, chances are it's going to be real and irrational. If you have a negative number on the inside and you're dealing with an even index number, chances are it's going to be imaginary. But if it simplifies to a nice number, then you know it's going to be real and rational. So that's it for this video. Hopefully it gave you a good introduction into real numbers, including imaginary numbers, whole numbers, integers, natural numbers, rational, and irrational numbers. Thanks for watching.